Now, lads, what I'm quickly going to do is I'm quickly going to enter these into the GeoGebra function, just to give you a taste of what each one looks like. So here's what I want you to do first. I'm going to call out, you're going to call me out what each one is in a second. Killian, that's your job, okay? You have the question in front of you? 12.8, question 1. Alright, really quickly. Y equals 2 to the power of x. Is that the first one? Yeah. Okay, so, does everybody see what it looks like? So which one does it match up to? Which one in the question does it match up to? It could either be B or C. What's the best way to find out? Insert a y value of 0. Oh, sorry, an x value of 0. So y equals 2 to the power of 0. So when x is 0, y is 1. 0, 1, that would mean this one is 2 to the power of x. Is that okay with you guys? Now, next one we could go for is 0.1 to the power of x. I reckon that one's going to be the shallowest one. Would you reckon that? It seems to be the smallest value, isn't it? So let's find out. So there's 2 to the power of x there. Next one I'm going to do is go for y. Killian, what is it again? Y equals? Yeah, 0.1 to the power of x. Oh. It's in the opposite direction. Do you notice that? Do you know why it's in the opposite direction? Because it's less than 1. If it's less than 1, it's in the opposite direction. Okay? Now, we can experiment with the numbers for a minute. Here's what we can do. We can plug in two values if you want. When x is equal to 0, what would the y value be? What's 0.1 to the power of 0? Y equals 1. So 0, 1 would definitely be a point. Now the problem with 0, 1 is it's in this one here and this one here. Does that make sense? Let's try another point. What happens when we do x equals, I don't know, x equals 1? What would be the answer then if we put in x equals 1? What would the y value be then? Y equals 0.1 to the power of 1. So this will be the point 1.1. Where is that one located? Yeah, it's tiny, isn't it? It's got to be A, doesn't it? Has to be A. It goes downhill. So that would mean that one's A, and this one we currently think is B. Which one do you think is going to have the steepest rise? 10 to the power of x, I reckon, will be much steeper than. Yeah, look at that. That's the blue one. Look how steep that is. How would you figure that one out really quickly? You just put in x equals 1. And what happens when x equals 1? Y will equal 10. And that's why it's out of the screen. So that will be, which one? A. And by process of elimination, that one will be C. Because it's half of 1. So, I think the gist of what we learned is that something we need to learn here automatically is if it's less than 1, if it's 0.5 to the power of x, what will happen? It will come in that way. If it's 5 to the power of x, what will happen? It will go the other way. Is there any way, do you have any method for checking that out in your calculator? Just use the table function. You can just do a quick sketch and you'll know which one's which, won't you? Alright, let's move on. That's question 1 done. Nah. Yeah, why not? State which of the following graphs is increasing or decreasing. Alright, this shouldn't be too bad. We sort of have the gist of this already. Okay. The first thing I want you to know is whether it's alright, we can do it by calculator or we can do it by just knowledge. We'll do it by calculator here for a second. Everybody really quickly. Is the number less than 1? Less than 1, less than 1, bigger than 1, negative power. I don't know how that affects it. I'm going to have to find out, haven't I? So let's find out. Alright, what do we think about this one? What do we reckon? I reckon it's going like this to you. Can't be negative, can it? Why can it not be negative? Why can it not go below the x-axis? Power is always positive. Alright, let's find out. Alright, so if you're worried about that, just go into the table function, go to menu, table, enter it in, 0.25 to the power of x, do your usual trick, go 5 to the left, 5 to the right. Step of 1. We can say it gets big at -5, and then as it gets closer to an x value of 0, what happens? It gets smaller, and then it continues to get smaller, but it'll never, ever, ever cross the x-axis. Is that downhill or uphill? Bit of a downhiller, isn't it? So what would that mean? Increasing or decreasing? Decreasing. The y value is always getting smaller. So this is decreasing. Okay. The next one, same deal, isn't it? Decreasing. The next one after that, if you aren't too sure, come in here and do 4 times 2 to the power of x. Right? Have a look at your numbers. What's happening to the number every time? What's happening? It's getting bigger every time, isn't it? So what does that mean? Increasing. Do the next one in your calculator. God bless the table function. So lazy. I didn't have it when I was in school. Good. I had to do everything out. Alright. It's really large at the start, and then what happens? And does it continue to decrease? It's always going to decrease. Everybody cool with that? Now, just for argument's sake, I'm going to show you the difference between 2 to the power of x and 2 to the power of minus x, just so you can see it. Okay? So here's what we're going to do. 2 to the power of x is the green one, and 2 to the power of minus x will be the other one here. They're symmetrical in which axis? Symmetrical in the y-axis. Everybody cool with that? So that's the difference. One of them is always increasing, the other one's always. Right, that's the difference. Right, handy out. 3's done. Now, which one do you want, 5 or 6? You can't have both. Alright, I'll do 6, you do 5 after I'm done with 6, okay? Guess what? You picked the easier one. Now, no, you don't. The number of days D that a yogurt stays fresh is stored at a temperature T is given by the following formula. Now, the first thing I do when I see something like that is I just lob it straight into the calculator and have a look. Okay? So, I'm going to put in table function, mode, table function. I'm going to do 18. I'm going to do 0.72. And then I'm going to do to the power of x. And I'm going to start at, can I start at a negative value? Surely I can. Because temperature is actually able to be. Can you store something in the freezer at -10? You can freeze stuff, can't you? So why don't I go for -10 and I'll go to +20. I'll do a step of 2, just for argument's sake. Should fit. Alright. Oh, lovely. If I freeze that at -10, I can store it for 481 days. That's consistent with science, isn't it? That if you freeze stuff, it lasts longer. If I freeze it at -2 degrees, I can store it for roughly 35 days. If I store it at 6 degrees, I can only keep it for 2.5 days. This is a good question. And if I store it at 10 degrees, I can only keep it for 0.67 of a day. Do those numbers make sense? They make physical sense as well, which is great. Now, I need these numbers here. So what's the cheap way of getting these numbers? Table function again, except each time you're going to have to show your workings. So this one's to the power of 5. The next one's to the power of. Next one's to the power of 2. And the last one's to the power of 0. Okay. Now, that's going to be 18. I have the answer for 2 already. So let me get me the answer for 5. 9.33. And we got the answer for 5. Anybody thought? 18 times 0.72 to the power of 5, please. Thank you. 3.48 days. Okay. Now, estimate the temperature. Did I even draw this? Nope. Is this an example of exponential growth or decay? Explain your answer. Which one is it? Decay. What's the reason? It's at its largest value for negative values for negative values of t. As t gets bigger, the number of days you can store it in the fridge becomes smaller. Does that make sense? It becomes smaller by 0.72 each time. So our example is, let's start off at day 0. But everybody agree it's 18 at day 0. Everybody agrees it's 18 at day 0, yeah? Multiply by 0.72. There's day 1. It's 12. Multiply by 0.72 again. Day 2 is 9. Day 3 is 6.7. Day 4 is 4.8. Day 5 is 3.4. 6, 7, 8, 9. You get the gist, don't you? The length of time keeps getting multiplied by 0.72. So you only get 72% of the amount of time you got from the previous stage. Does that make sense? Each day it decreases by 28%. 28% of your time is lost each time. Where did I get 28 from? 1 subtract 0.72. You retain 72% of your time, or you lose 28% of your time each day. Or sorry, for each degree in temperature, by fault. Each degree in temperature, you lose a certain amount of your time. Okay. Estimate the temperature required to keep the yogurt fresh for at least 5 days. All right. Here it is. Right, ready for this? Go back to your table function. Oh, we need logs for this, but anyways, we'll give it a go. 18 times 0.72 to the power of x. Start at -5, end at 5, do a step of 1. What are we looking for, guys? 5 days, is it? Somewhere in between 3 and 4. Anybody have a cheat for me? What should I do now? Go back again. Start at 3. End at 4. Step of 0.1. Now look. Still looking for 5, haven't I? Keep going down. 3.9. It's pretty good, isn't it? You ain't getting any closer, are you? So what do I do? I'll just say temperature is 3.9 degrees. Does that make sense? And how do I show the workings? Oh, I somehow came up with this magical number that's ridiculous. What that is ridiculously accurate. Cool. You pull it out of nowhere and just plug it in, and that's you showing your workings. Okay? Now, you guys are going to do question 5. Enjoy.